Here's our code for lab number 7. Here we're uploading to the robot. Bottom right is done compiling. Our robot is ready to move. 1 second, cool. Now it is ready to disconnect. Place it on our beginning mark. Notice that the right wheel is lined up, the center of the right wheel is lined up to the corner of the tape. And when we press A, the robot will wait 2 seconds and then begin. The second piece of tape is a 24-inch mark. Then it will rotate 90 degrees and continue through the whole sequence. As you can see here, when it's completed, it is within 1/4 of an inch from its initial starting point. For the code, we begin with our functions we're using, some of the things we enabled on our Romi robot. These are all of our defined constants. We have a couple of variables, global variables that we established. We had some issues with our functions where it kept wanting us to declare the functions before we called them, and so we use function prototypes to get around that so we can still have the functions below our setup, our loop. In our setup function, we have our basic, we have pretty much nothing. It turns on a green LED to let us know the code is ready to execute. In our loop, we set a wait for button A and then delay 2 seconds to get the required delay, and then it moves through a for loop from I equals 0 to I equals 3, so that's a total of 4 times. It'll move straight our required distance, which is 24 inches, and then rotate 90 degrees. We use the calc pulse statement to calculate the number of pulses required for any movements. We have a ramp to speed function used in our straight function in order to reduce the jerk and increase our accuracy in movement, because we found that if we go directly to 80 speed, we were getting a little bit of slippage between the wheels and our surface. Straight functions as expected, move forward. If you give it a negative distance, it'll move backwards, and that's what all this funky stuff is. And we finish with a ramp down to 0, and then sets the motor speed to 0 to make sure we've hit our target, to make sure we stop moving. Rotate, pretty basic. We add a little bit of an overshoot in order to make sure it's closer to 90. But regardless, we use some basic algebra, calculate the required number of pulses as we went over in class. Reset our counters for our encoders, and then we manually set the speeds here to 80 in order to get it to speed, and then once it's finished rotating, it goes to 0.